So we calculated the decision boundaries b of k, but we still need the reconstruction values y of k. So to obtain them, we can again take the derivative of d and set it to 0. But there is one problem. This time we cannot make the assumption that the probability function is constant, yeah? Because now we would like to have a dependency on a non-uniform PDF. Yeah? We could make this assumption before because we only assumed it for the small quantization intervals. Yeah? This can be true in practice also for non-uniform PDF if we have enough quantization intervals. But to keep this dependency on the PDF for the reconstruction values y, okay, we will go back to this equation here, the original formulation of d, and we will have the PDF p of x and the reconstructions values, or the code words, y of k, yeah? And we'll take the derivative of this with respect to y of k and set it to 0. So this is what we are doing here, yeah? So from here we go to here. We'll take the derivative with respect to y of k and set it to 0. So we have also here using SymPy. But since the y of k is only in one interval, this sum disappears. So we can remove the sum. We'll remove the sum. So this is the derivative of y of k, and y of k is only in one interval. So the sum disappears, and we have this. And when we take the derivative of this with respect to y of k, that's what we are doing here. So we end up with this equation here, which is similar to this one. Now we have a sum. So we have this minus 2x p of x dx, and we have, so there's a sum here. We can split this integral in two parts. So this is what we are doing here, and we get the final result that the y of k, there is this numerator and this denominator going from b of k minus 1 to b of k. So the decision boundaries, we have our signal x, we have the PDF of our signal, and this is what we are doing also in SymPy. So we had this equation here. We are splitting this integral in two parts, and we end up with the y of k. We are solving this equation for y of k. So this is what we are doing using SymPy, and we have exactly the same result. Yeah? Now we got a result without making any assumptions of the probability function. Yeah? This can be interpreted as a conditional expectation of our signal value over the quantization interval. Yeah, or also it's the centroid. It's centroid as a reconstruction value or code world. Yeah? The value in the numerator can be seen as the expectation value of our signal in this interval, and the denominator can be seen as the probability of that signal being in that interval. So we have this equation with the numerator and denominator, and we can observe these two things here. Yeah? It can be interpreted as, given the signal is inside the interval, this is the average or expected value. Yeah? So the decision boundaries depend on the reconstruction values y of k, and y of k depends on the b of k, so we need to come up with a way to compute them. And what we do is to have an iterative algorithm.